I welcome all the students. Today we are going to start learning the unit or the topic which is called as visible surface detection and animation. Okay, so our main focus will be on the different algorithms comes into the visible surface detection, and then we discuss in this unit about the animation. Okay, so today's topic of the discussion in today's session, we are going to cover the visible surface detection. You understand the basics of visible surface detection. Okay, we are going to consider what is mean by visible surface detection, and then we are going to consider, okay, the point classification of the visible surface detection algorithm. Okay, so which are the different types or classification of this, and then we are going to cover the point the backface detection method. So this is the first method or algorithm we are going to learn, okay, having the name backface detection algorithm. Okay, so today's topic of discussion is under visible surface detection we are considering the classification, and then we are considering the backface detection method. See, the meaning itself indicate visible surface detection. Okay, so whenever we are looking to any three-dimensional object, okay, at that time, and when I convert that visible or three-dimensional object in the form of the 2D, so in such a case we have to display only the part of the object which is visible to the user or visible to the observer. Okay, now the first point which is mentioned here is in realistic graphic displays. Okay, it is important to identify those part of the scene. We are going to identify only those part of the scene that are visible from a chosen viewing position. Okay, so from a particular position or the position of that camera or the human eye, whatever the part is visible, okay, in that particular image, only those part we have to identify and we have to display. Okay, so that's why the name is given as visible surface detection, because we have to identify, we have to detect the part of the scene which is visible, and then we are going to display only those part of the scene. Okay, so this is what we talk about visible surface detection. Now there are various algorithms are available. Okay, so that's why I have mentioned here various algorithms are used for efficient identification of the visible objects, okay, for a different types of applications. Okay, so depending upon application I can select so many algorithms are available. We are going to consider some of the important algorithm, okay, in this particular unit. Okay, so now here we are considering the next point is some required, some of the applications required. Now suppose I'm having so many algorithms, okay, then every algorithm may have some merits and demerits. Okay, every algorithm having its own advantages and disadvantages. Okay, for example, some of the algorithm requires more amount of memory is required, whereas some algorithm requires more processing time. Okay, time in some of the algorithm memory requirement is less but the processing time is more. Okay, whereas some apply only to a special type of object. Okay, I mean for some special object the method is applicable efficient, but for other objects I cannot apply the method. Okay, so these are the different comparison or the parameters, okay, that we are having while we are going to select the particular algorithm. Okay, so as I am having various algorithms are available for visible surface detection. Okay, so we need to select among which algorithm is suitable. Okay, so that's why I have mentioned this point. So there may be these parameters are there, maybe memory requirement, maybe the processing time, okay, maybe whether it is applicable to all the type of object or only it will applicable to some type of the object and so on. Okay, so that's why we are having these points I have mentioned. Okay, which algorithm to be used or which algorithm is suitable for me. Okay, out of all these various algorithms available, so which is suitable, it depends upon the following parameters. Okay, so I've just listed which are the parameters on which it depends. Okay, so these parameters that we are having are the particular application. See, my algorithm which I should choose depends upon the particular application, means I am going to apply it where. Okay, which type of application I'm going to apply, so that is important. Second point is the complexity of the scene which is involved. Okay, whether my I'm applying my method, okay, need to work on a complex scene or a normal scene. Okay, so we have to check the complexity of the scene which is involved. We also have to check the type of object to be displayed. Okay, so we have to consider what is the type or which is the type of object that I'm going to display. That also we need to consider. We also have to consider the available equipment. Okay, so whatever I'm proposing, whether it will be available, those equipment will be available or not. And at the end, or the one more point that we need to consider, that the static or animated displays are to be generated, whether my displays are static or whether it is dynamic or in the form of the animated displays are there, that we have to consider. Okay, so whenever we are going to select any algorithm out of the number of or various algorithms available for the visible surface detection, we have to consider all these parameters. Okay, and depending upon this parameter, I can select that yes, this is the algorithm, okay, which is suitable for my particular application. Okay, and I'm going to use this. Okay, so this is what the background that we are having. Okay, so let us continue our discussion. Okay, I'm just moving to the next slide now. Okay, let us consider this. Now, all these algorithms that just now we have discussed are known as, okay, so what is the name of all these algorithm is? They are known as visible surface detection methods or algorithm. Okay, these are known as visible surface detection method. Okay, now if I take the reverse case of visible surface detection, so these methods are also referred as, okay, hidden surface elimination method. See, what I'm doing, I'm detecting and showing only visible surface. It also indicates that I don't have to show the hidden part. Okay, so this also indicate that these algorithms are also referred as hidden surface elimination, because I'm going to eliminate the hidden part from the image. That is what I'm displaying, the visible part of the image. Okay, so both the names are given, so I can call it as a visible surface detection method or algorithm, or I can also call these methods as hidden surface elimination methods or algorithm. Okay, so now what exactly my visible surface algorithm does? Okay, so that's why I've highlighted this point. The visible surface algorithms attempt to determine, okay, they are going to attempt to determine the lines, edges, surfaces or the volumes that are visible to the observer. Okay, what I'm going to determine, what these algorithms are going to determine, they are going to determine the lines, edges, surfaces or the volumes that are visible to observer located at a specific point in the space. Okay, so considering the position of the observer, okay, which is located in some specific point, we have to find out, if I looking to the object from that particular point, okay, from that particular position, then we have to find out which is the part or the surface which is considered to be visible. Okay, and that we have to show. Okay, so this is what we are considering now. To understand this, I have shown this following diagram. The following diagram shows this as an example. Now what is my aim or what is my purpose of calling it as a visible surface which I have to display, and what is mean by the elimination of the hidden lines or the surfaces? Okay, so that's why I'm having this diagram to be displayed. Okay, now what this diagram shows, okay, it shows that the need for the hidden surfaces. Okay, for example, this is my diagram number A. Okay, so this is my diagram number A. If you look at this particular diagram, which is of a unit cube, okay, it is a cube diagram, you can find all these are dotted lines are there. Okay, so this is my actual object. But if the user is looking to this particular object, okay, that is shown in the diagram number B, if I'm going to view from the left above, okay, if I'm looking to this particular object from the left side and from the top side, left top side, I'm looking to the object, okay, then obviously my object will look like as shown in the diagram number B. Okay, now in this particular case, I say this is my surface which is visible, this is the surface which is visible to me, this is the surface which is visible to me. Okay, and which are the lines or the surfaces which are not visible to me? So in that case, suppose I consider the lines, then I'm just marking it here. This is my visible line. This line is not visible. Again, this line I'm considering it is not visible to me. Getting me? It means this line is hidden. Okay, if I consider this side, again I consider this is my line which is hidden. At the same time, I can say if I'm looking to this particular object from this particular point, then I can say this is the back part. Okay, so this whatever I'm considering is this particular side which is at the back side, which is not visible. Again I'm having this is the part which is not visible. I'm again having this is my uh, bottom part which is not visible. So I consider this C, but which is visible? Yes, which is shown here. So these are the three parts which are visible to me, okay, which I have shown or which we have displayed on the screen. Okay, so this is, so what my algorithm should do, my algorithm should find out from this particular object. So this is the input object to my visible surface detection algorithm, and I should get the output which is similar to this. Okay, again it depends upon from which position I am looking towards the object. Okay, here I am looking to the object from the left above, so I get this particular diagram. Now the same object, that is the diagram number A, okay, same object, that is my diagram number A. If I am going to look this object from the right below or right bottom, I'm looking from the right side, okay, as well as the bottom side, means this is my position of the observer, okay, right side, but again I'm going to look at the below. Then I found that in that case my top surface is not visible. In diagram number B, top surface is visible, which is displayed, but in this diagram top surface is not visible, but rather the bottom surface of the object is visible, which is shown here. So I can see the bottom surface, I can see this particular view, as well as this surface is visible, which I have displayed. Okay, but other views are not visible in this particular case. So all such views which are hidden, okay, that should be eliminated. So that's why we have given the name as hidden surface elimination. You can find it here, hidden surface elimination, or I call it as visible surface detection, because this is something which is visible to me, okay, which is not visible, okay, or which is hidden, don't display it, okay, eliminate it and show only the part of the object which is visible. Okay, and that is what the point of discussion that we are having, and we are calling it as a visible surface detection. Okay, I think this diagram and the explanation that we are having, I hope it has helped you, okay, to clear the point or the concept what is meant by visible surface detection. Okay, so let us continue our discussion. I'm just moving to the next slide now. Okay, so now we are moving to the understanding the classification of visible surface detection algorithm. So are there any types of visible surface detection algorithm? Are there different, okay, or whether the categories are there, whether I'm divided this algorithm into different categories or the classes? Okay, so that we are going to learn, and this is known as the classification of visible surface detection algorithm. Okay, now here I am mentioning the visible surface detection algorithms are classified as, means there are the two types of the type we are having. The one is known as, first category or first classification is object shape method, with a visible surface detection which uses the object space method. Okay, object space method, so that is my first type, and my second type is image space method. Okay, so these are the two types I'm having, object space method or it is a image space method. My algorithms are categorized, or my algorithms are divided into two categories, whether it is based on the object shape method or whether it is based on the image space method. Okay, object space method and image space method. Okay, let us understand these two terms, okay, one by one. So the first term that we are having, object space method. Okay, now what this object space method does, it compares objects and parts of the objects to each other. Okay, so here what I'm comparing the object and the parts of the object with each other. Okay, within the scene, okay, definition, within the scene definition, to determine which surface as a whole we should label as a visible. Okay, so it completely depends upon whether the image is having how many objects. Okay, so it will compare all the objects as well as it is going to compare the parts of those objects, okay, parts of the object with each other in my scene definition to determine which surface as a whole we should label as visible, which surface or which object is visible and which is not visible. But for this comparison I'm considering the object, I'm comparing the object, or I'm comparing the parts of the object. Okay, so that's why the name the given as object space method. Okay, I'm dividing my scene in the number of objects. Now, this method can be effectively used also to locate the visible surfaces, okay, but the percentage is less, okay, as compared to the image space. Okay, it is effectiveness is considered to be less because it will be useful for certain application. Now, where it is useful, so this is what we can say, the object space method, okay, is used, or the line display algorithm, means my all line display algorithm generally uses the object space method. So object space methods are used by the line display algorithm to identify the visible lines in a wireframe display. Okay, so where or which type or which algorithms uses this, so object space method is used by the line display algorithms are uses to identify the visible lines. I want to identify the visible line in wireframe displays. Okay, so in such a case, I will consider the classification method, or the type of method I use is object space method is used. Okay, now what is my second method? So my second method is image space method. Okay, my second type or second method of visible surface detection algorithm is image space method. Now here, what is mean by the image? Previously we considered as the object, okay, but what is my image space method is image space method indicate that in this method the visibility is decided point by point or pixel by pixel. Getting me? So if I am considering the image or complete picture in the form of point by point, or I am considering the visibility at each pixel position. So if I am considering the image the pixel by pixel, not object by object, then it is known as image space method. Okay, so in this method, I read this again. In this method, visibility is decided point by point at each pixel position on the projection plane. Okay, so this is what the difference we are having between the object space method and image space method. Okay, so I am doing all these algorithms work on the pixel by pixel position or point by point position. Okay, now most visible surface algorithm, and this is I just want to mention that most or maximum visible surface algorithm are uses or they based on the image space method rather than the object space method. Okay, so they are going to use the image space method rather than using the object space method. Okay, but again it depends upon the application that we are having. Okay, now many image space algorithms can be adapted easily to visible line algorithm. Okay, why these are mostly used? Okay, maximum algorithms why they are using, because the image space algorithm can be adapted easily. Okay, it is more easy to adapt it or use it for the visible line algorithm. Okay, so this is what about the two types of the visible surface detection algorithm or the classification of it. One is just now we have seen object space method, and this is the second method. I call it as the image space method. Okay, so now I think our discussion of these two methods are over, but now we are considering what exactly these methods are. Now this is not the part of the image space, but it is applicable to both. Okay, now what it is, most this method uses the sorting and coherence methods also. So some of the method uses first the sort the object or sort the part of object and use the coherence also, okay, to improve the performance. So I'm using the sorting as well as I'm using the coherence methods inside these two types of the methods. Now I'm not considering it is applicable to only image space. It is applicable to both whatever I'm discussing, and all this is used to improve the performance. Let us understand what exactly we are doing for the sorting and what we mean by the coherence. Okay, so the sorting, okay, sorting is used to facilitate the depth comparison. We are going to compare the depth, okay, of that particular object to depth comparison by altering the individual surfaces in a scene according to their distance from the view plane. Okay, so what I'm going to do, I'm going to use the sorting method to facilitate the depth comparison. Suppose I'm having the three objects, I will compare all these three object depth value or the z value I'm going to compare. Okay, and then I'm going to sort these objects with respect to their z value. Okay, so that's why I require the sorting method to be used in this particular case. Getting me? Now if I just continue, what is mean by the coherence method, I just want to mention it here. The coherence methods are used to take advantage. I think we already discussed this or know about the scan line coherence as well as the area coherence. Okay, so coherence is also divided as scan line coherence or area coherence. Now what it means is, it means that the coherence indicates the methods are used to take advantage of the regularities in a scene. Okay, take advantage of regular means if I consider scan line coherence, means on a same scan line the maximum pixels are of the same type or same characteristic, they are having same characteristic, is known as scan line coherence. If I consider area coherence, then it indicates that the part of the area or the part of the image, okay, is having the similar thing. Suppose I consider background, generally the background area, that particular part is having the same characteristic, okay, and that is called as the area image coherence, or we can consider it as a also the scan line coherence. Okay, these are the two things which are internally used in my visible surface detection algorithm. So it may uses the sorting, okay, or it also uses the coherence. Okay, the sorting is based on the depth comparison of the different objects that we are having. Okay, so I consider this is all about our discussion of the point what is mean by the classification, or which are the different two classes are there for the visible surface detection algorithm. So my algorithm may come into the two categories, maybe the object space method, or it may come under the image space method category. Okay, so it is very easy for everyone to understand these two methods now. Now with this, whatever the background we have learned, see, until now we have learned what is mean by the visible surface detection first. Okay, what is meaning of the visible surface detection, or what is the meaning of the hidden line elimination or hidden surface elimination. Okay, and then we have seen which is the classification of this algorithm. Okay, now we also seen various algorithms are available. Okay, now out of these various algorithms which are available, now we are moving to our next point to understand the first algorithm, okay, that we are going to learn under the visible surface detection. Okay, and what is the name of my this algorithm? The name of my algorithm is backface detection. Okay, so I'm just moving to this particular point, and let us start understanding. And now we are having the discussion on the backface detection algorithm. Okay, how I'm going to detect the backface. Okay, backface detection algorithm. So this is my first algorithm which is under the, which comes under the visible surface detection algorithm. Okay, and maybe the next session we go for the next algorithm. We are going to learn two more algorithms. So let us first understand what is backface detection algorithm. Okay, now a fast and a simple object space method for identifying the back faces. I want to find out which is the back face of this object. Okay, if I identify the back face, then I'm not going to display it. If it is a back face, it is not visible. If it is a back face, it is not displayed. Okay, so that's why the name is given as it is the back faces of a polyhedron is based on the inside outside test. Okay, so this back face detection, what it is going to identify, it is identify the back faces of any object. Okay, it is going to identify the back faces of the object, and it is based on the inside outside test. Okay, so we are going to use the inside outside test for this particular purpose. Now here, how the point is represented. Okay, now we are considering that a point x comma y comma z, because it is, we are considering three-dimensional object is there. Okay, consider my point x comma y comma z is inside, my point is inside a polygon surface with the plane parameter. So now I'm considering, as I'm having the x, y, z, these are the parameters x and y and z. These are the parameters for the point. Okay, similarly I'm having the parameters for my plane or visible plane. Okay, from which angle I'm accessing, from which angle I'm looking to the object. Okay, so similarly I'm having the plane parameters are a, b and c and d. I'm having the plane parameter a, b, c, d. Okay, if, now what is my condition? When my point xyz is inside a polygon surface, when it is inside, if ax plus by plus cz, okay, plus d, okay, if it is less than 0. Okay, so this is the formula that we are using. Okay, so ax plus by plus cz plus d, okay, if it is less than 0, then it indicates that, okay, my point is inside the polygon surface. Okay, so that is what we are considering. Now, when an inside point is along the line of sight, okay, if the inside point is along the line of sight of the surface, the polygon must be a back face. Okay, so if I found that my pixel is less than, having the value which is less than 0, okay, that is when an inside point is along the line of sight, okay, it is along the line of sight to the surface, okay, the polygon must be a back face. So we are considering the polygon is considered to be a back face. Now we can simplify this test. Okay, whatever now we are discussing, we can simplify this test by considering, okay, whatever just now we have discussed, I can simplify this with the help of by considering a normal vector n. Okay, so consider a normal vector n to a polygon surface, normal vector n to a polygon surface which has the Cartesian component a, b and c. Okay, so that's why we are taken these values as a, b and c. Okay, so these are my Cartesian component of my normal vector n, a comma b comma c. Now in general, okay, we are considering it as the v is a vector. In general, I consider vector is represented as capital V. Capital V is a vector in the viewing direction. Okay, it is in the viewing direction from the eye or the camera. So my v is a vector is in the viewing direction from my eyes, okay, or from the camera position as shown below. Then this polygon, we are going to see the diagram also, then this polygon is back face. Okay, considering the vector n having the Cartesian product a comma b comma c, I say the polygon is back face if the v into n, so vector v into n, okay, that is my normal vector n, if it is greater than 0. Okay, if it is greater than 0, I considered this is a back face. Okay, now to understand this particular point, okay, let us understand one diagram, that what is v, what is n, what is my point, or what is the back face I am detecting. So that's why I'm having in my next slide, I'm showing this particular diagram. Okay, now look at this particular diagram now. Okay, what is the diagram says? Vector v. Okay, so this is my visibility. V stands for vector, for that is visible angle. This is my angle of my camera, or this is my visibility angle. Okay, in the viewing direction. So vector v is in the viewing direction. You can find this is my camera, okay, and this is my viewing direction, and a backface normal vector n. Okay, now whatever the n I'm having, so n is my normal vector, n is having this value a comma b comma c of a polyhedron. Okay, now if I look at this particular diagram, okay, you come to know that, see, okay, I'm looking to this particular object from this particular position. This is my position of my camera and this is my angle. See, if this object I'm looking from this particular vector v, then obviously this surface is visible. Okay, this surface is visible to me. Okay, but what about this particular surface? Okay, I'm talking about this particular surface. So this surface, okay, is back face. I find out that this surface is back face. Okay, because this is visible, this is not visible. So this surface is back face. If I'm looking, see, I'm looking from this particular angle. Okay, so definitely this is my back face, and that is I have identified with the help of this formula. Okay, and we have to detect that back face, and obviously if it is a back face, it will not be visible, it will not be displayed. Okay, so find out the back face and then don't display that back face because it is at the back side, it is not visible to the user or not visible to the observer. Okay, so now continue our discussion of the backface detection algorithm. I'm just moving to the next slide. I hope all of you understood. This diagram shows what is my camera position or my visibility and my vector v, and now my vector n, which is considered to be a backface normal vector. Okay, that is I'm having the values a comma b comma. Okay, now here furthermore what we are considering, if the object description have been converted to a projection coordinates and our viewing direction is parallel to the viewing zv axis. Okay, my viewing direction is parallel to my uh, viewing position having the z value, so I call it as zv axis, then my normal vector v, okay, you will be having the value 0 0 vz, because I'm displaying whatever I'm looking towards the 3D object. Okay, I'm just going to see my xy plane, means I'm going to show only the 2D object. Okay, out of that 3D object I'm just displaying the 2-dimensional object, and that is considered to be with the 0 0 x and y will be displayed, and whether to display the z, it will depends upon the depth value. Okay, so then v is equal to 0 0 comma vz, and I can apply this formula now is v into n is equal to vz into c. Okay, v is my vector, into n is my normal vector, okay, having this value a b c. Okay, then this is equal to vz, means now I'm considering my visibility, or the vector is having the z value I'm considering into the c. Okay, so that we only need to consider the sign of c. Here we am going to consider only sign of the c, whether it is positive or whether it is negative. Okay, the z component of the normal vector n. Okay, now here, okay, now I want everyone to look at this particular diagram, similar diagram that we are having previously. Okay, I first read what is the diagram description. A polygon surface with the plane parameter c is less than 0 in a right-handed viewing coordinate. See, this is my I'm looking to this object from the right side. Okay, so this is my v. My viewing position is at the right-handed. Okay, right side I'm going to look at this object. Viewing coordinate system is identified as a back face when the viewing direction is along the negative zv axis. Okay, now here if you look at this particular diagram, see, this is my zv axis. I'm viewing with the z value here. Here is my x and this is my y value, yv, and this is xv. Now if I'm looking to this particular direction, definitely this will be visible surface, and this part which is shown with the blue color is my having my normal vector n is equal to a comma b comma c, which is my back face. Okay, so now I'm having the further discussion. I think we have to consider here. Okay, yes, definitely it will be considered as a c is less than 0. Okay, because here we have mentioned there is consider only the sign of c. If it is c is negative, okay, then the near coordinate consider of the vector will be at the back face. Okay, now for that I'm just continuing our discussion. Okay, so the equation further that we are having, okay, I'm going to normalize this equation or solve this equation. Okay, and I'm just moving to the next slide. Okay, definitely we consider this diagram again, the next slide, to understand it. Now in the right-handed viewing system, we have just seen the diagram of this. The right-handed viewing system, the viewing direction along the negative zv axis is shown in the diagram. Just now we've seen this diagram. The polygon is back face. Okay, the polygon will be at the back face if the c is less than 0. Okay, if the c is less than 0, indicate that the polygon is at the back face. Also, we cannot see any face whose normal vector has z component c is equal to 0. If c is equal to 0 also I cannot see. Okay, if c is less than 0 I cannot see. So I want c value should be having greater than 0. It should be greater than 0 since our viewing direction is grazing the polygon. Okay, I'm going to graze the polygon. Okay, see what it means is if anything is in front of my, it is very close to eye. Okay, it is something is very close, very closest to my eye. Okay, having the z value or the depth value is exactly 0, I think it is not possible also to visualize it. Okay, so if I'm just moving my hand further, so z value is positive, greater than, it maybe have the value, okay, greater than 0. Okay, then I think it is possible for us to observe or to have the visible surfaces. Okay, thus in general we can label any polygon as a back face. Yeah, I'm going to label any polygon as a back face if its normal vector as a z component value, normal vector is having the z component value, c is equal to less than or equal to 0. Not only less than, but I say it is less than or equal to 0. Okay, then it is a back face. See, we have taken the vector is having three parameters a, b, and c. A is for x, b is for y, c is for z. Getting me? C value is for z. So I'm say that z component value c, if it is less than or equal to 0, okay, if it is less than or equal to 0, indicate that the polygon or that particular surface is at a back face. Okay, so that is what we are considering, which is back face. And if it is c value is greater than 0, if it is having some value, okay, that plus 1, okay, or greater than 0, means it is visible. And if it is having the c value less than or equal to 0, means that polygon is at the back face. And now I talk only about the z component value. There is no need to consider the xy component value. We can consider only the z component value for this particular purpose. Getting me? So let us look at this in the detail with the same diagram that we have displayed. Yes, you can visualize the same diagram here. Now you can say, now you can consider here the normal vector is having the parameter a, b and c. Okay, now in this particular case I'm having the right-handed system. This is my z value, this is my x value, and this is my y angle, xy angle. Now here I just considered the comparison. If this is the z component, okay, with the value c, okay, so this is the c parameter for this, and if it is less than or equal to 0, if this particular component is less than or equal to 0, indicate that this particular surface, which is shown with the blue color, okay, this particular surface is at the backside. If I take this particular point, okay, if I consider this point, now this point is having the z value, z component value, which is represented by the c in my normal vector. Definitely it is positive value. Okay, but now for all others, okay, if it's something, suppose I consider this my 0 0, okay, taken the position over here, okay, then the remaining will be having the depth value or the z component represented by the c value is less than 0. Okay, so if it is less than 0 value, then it is back phase. Okay, if it is not less than 0 value, less than or equal to 0, it is greater than 0, then it indicates that it is at the visible phase and that we have to display that particular component. Okay, so this is what our discussion, or the with the help of some mathematical equation and the part that we have display considering what is the back phase detection. Okay, so this is what we are considering. Now I just continue with one more slide to understand the backphase detection algorithm. See, backphase detection algorithm may not be applicable to all type of object. Okay, it may be applicable for some type of the object, but I cannot say it is applicable to this algorithm applicable to all type of the object. Okay, so that is what I'm discussing in my next slide to understand this particular point. Okay, I just move to the next slide now. Now here what I'm saying, for other objects, okay, such as concave polyhedron, okay, so it is not the normal polyhedron, it is a concave polyhedron in the diagram. The more tests need to be carried out. It's my backphase detection algorithm is not applicable there. I have to carry out more tests need to be carried out to determine, okay, what I have to determine, whether there are additional phases that are totally or partly obscured by other phases. Okay, so I have to find out this, so I require some more additional tests. Okay, so I can say if I'm using backphase detection, that is not sufficient for me, I have to perform some additional phase in such cases. Okay, just look at the diagram here. Okay, so that's why I have shown this particular diagram. Okay, view of a concave polyhedron with a one face partially hidden by other faces. One face is partially hidden by the other faces. So if you look at this particular diagram, I say that this is my back face. Okay, I see I have detected this as a back face having the z value, but this face I can say it is partially hidden. Some part is partially hidden, some part is not partially hidden. Okay, so in such cases, such objects are required to go for the additional tests, okay, in my backphase detection algorithm. Okay, I just continue the discussion. And a general scene, okay, and the general scene can be expected to contain overlapping objects. So it is having overlapping objects along the line of sight. Okay, this is my line of sight. It may have the so many overlapping objects are there. In such a case, my normal backface detection, whatever you have considered, it will not 100% show the partial faces are there also. Some faces are partial which may not be detected into the backface detection. So we required some more tests, or we required some additional tests to be needed. Okay, so that is what we are considering in this particular diagram. Okay, so this diagram or this type of the concave polyhedron, okay, which is may have some partially hidden faces are there, and these may not be detected appropriately by my backface removal or backface detection algorithm. Okay, so here this is I just now I altered this word. In some of the textbook it is also referred as backface removal algorithm. Okay, the meaning is same, backface detection or backface removal algorithm. Okay, so different textbook or different book refer this as, instead of backface detection, they also refer it as a backface removal algorithm. Okay, So I'm just discussing one more point here. We then need to determine whether the obscured objects are partially or completely hidden by other object. One object is partially hidden by the other object, it may be completely hidden by the other object. Okay, in front of one large object, I may have back end, it may be the small object over there. If it is completely hidden, okay, due to the front side higher large object, then it is not displayed. But it may happen that in some of the cases, okay, that obscured object, okay, may be partially hidden by the other object. So partially means other part should be displayed or other part is visible. Okay, that I need to consider or I need to detect over here. Okay, so now for this particular purpose, that's why I have just mentioned this particular point as the last point related to the backface detection, or you may consider it as one of the drawback or the demerit of the backface removal algorithm. So in general, backface removal can be expressed to eliminate about half of the polygon surfaces, only for the half of the polygon surfaces in a scene from further visibility test. Okay, so in such a cases, if my object is complex, okay, it is having the multiple object, some are partially hidden by the other object. In such a case, my backface removal can express only, or it is going to eliminate only half of the polygon surfaces, not the complete scene. So we required to go for the further visibility test or further algorithm that we need to go for. Okay, so that's why I say the one of the first algorithm that we are having, okay, and that is known as backface detection algorithm. Okay, but for a normal or simple object it's going to do it. But if I'm having the more objects are there, okay, complex objects are there, where the backface detection will not uh, find out all the back faces or cannot remove all the back faces. Okay, there may be some partially hidden faces are there. Okay, so as we have shown in this particular diagram, so this particular face I can call it as it is partially visible. Okay, so this particular part is visible. Okay, this is partially visible to me. Okay, such cases I need to go for the further visibility test in my backface detection algorithm. Okay, I hope all of you have understood the first algorithm, that is known as backface detection, or some of the cases it is referred as backface removal algorithm. Okay, so today's our discussion we have learned the three important points. First one is what is meant by the visible surface detection. Okay, then we have seen the classification, which are the two types are there. Okay, it is based on the method called as a object space method, or another is image space method. And then we have seen in all detail the backface detection algorithm. Okay, so this is what I say our today's session of the discussion. Okay, so we will further algorithms we are going to discuss into the next session. Okay, where we are going to see the next algorithm. There are two more algorithms we are going to discuss. One is known as depth buffer algorithm. Okay, or this also known as Z buffer algorithm. And then we are going to see also the area detection algorithm, or it is related to the Warlock algorithm, and so on. Okay, so today we are going to end our session here. Okay, I hope all of you have understood and enjoyed the learning. Okay, so thank you all the students. Okay, thank you all.